Most of us learn a very neat model of the solar system in grade school. You have the sun in the center, 8 major planets, a smattering of smaller dwarf planets, and their orbiting moons. In 2006, the International Astronomical Union formally reclassified Pluto as a dwarf planet because it had not cleared its orbital neighborhood of other debris. But looking purely at physical size reveals a mathematical paradox. Pluto is physically smaller in both mass and diameter than 7 different moons in our solar system, including Ganymede, Titan, Callisto, Io, Earth's moon, Europa, and Triton. Our astronomical labels sort these objects by their orbits. However, focusing strictly on their path around the Sun prioritizes orbital geometry over the physical nature of these worlds. Jupiter's moon Ganymede is a primary example of this scale. It is larger than both the dwarf planet Pluto and the major planet Mercury. In 1996, NASA's Galileo spacecraft proved Ganymede is the only known moon to generate its own active magnetic field. Those magnetic lines create glowing ribbons of electrified gas. Using the Hubble Space Telescope, scientists tracked these polar auroras rocking over time. The mathematics of that motion proved a massive saltwater ocean sloshes beneath a 95-mile-thick icy crust. This moon contains more liquid water than all of Earth's surface oceans combined, making it one of the most geologically active environments in the solar system. Measuring these distant worlds is difficult. Sitting 3.7 billion miles away from Earth, Pluto received so little sunlight that early telescopes captured it as only a faint, blurry pixel. Even the Hubble Space Telescope reached its limit for accurate diameter readings. It took the New Horizons spacecraft flying directly past Pluto in 2015 to lock in its precise equatorial diameter at 2,370 kilometers. Combining its verified volume with Charon's gravitational pull reveals a density of 1,879 kilograms per cubic meter. This profile indicates Pluto contains more cryogenic water ice relative to its rocky core. This exact volatile mix drives tectonic forces, flowing glaciers, and 10,000-foot ice mountains. Pluto possesses a geological complexity that rivals many major planets. Its classification as a dwarf planet describes its location, but not its physical status. Historically, the limitations of early telescopes skewed our understanding of planetary scale, creating a bias toward objects that were closer to Earth or objects with specific atmospheric traits. Saturn's moon Titan is a perfect example. Through a telescope, it appears artificially massive because it is wrapped in a dense 400-kilometer-thick nitrogen atmosphere. Visual observation from a distance is deceiving. Establishing a true hierarchy requires the direct physical measurements gathered by spacecraft on site. If we uncouple a celestial body's orbit from its physical identity, the standard hierarchy of the solar system takes on a different order. Pluto forms a double planet system with its moon Charon, which is half Pluto's size and locked in a tight gravitational dance. Consider this thought experiment. If giant active moons like Ganymede or Titan were to break free and orbit the Sun directly, we would classify them as major planets without hesitation. The labels moon and dwarf planet are orbital addresses. In reality, the solar system is a vast collection of dynamic worlds, many of which contain the liquid water and geological energy necessary to be considered legitimate targets in the search for life.